When a trusted issuer signs your data, it becomes a verifiable credential stored in your wallet. Your wallet can then assemble a verifiable presentation, revealing only what's needed for a specific request. We'll anchor on these two objects before we move into OIDC4VP and the trust checks around them. Up to this point, you've seen why an EUDI wallet onboarding solution matters and what it looks like in practice. We started from eIDAS motivations, passed through KYC requirements and GDPR controls, and arrived at a concrete architecture and flows. Now we zoom into the payload itself, verifiable credentials and presentations, so you're ready for the upcoming OIDC-based protocols. You can think of a verifiable credential as a digital ID card. An issuer, such as a university or bank, signs a set of claims about you and protects them so that any tampering is detectable. What you actually share, though, is a verifiable presentation. As the holder, you choose which credential data or specific claims to disclose, then package and send them to a verifier, who checks the signatures and status before trusting what they see. A verifiable credential is essentially a signed data package. At the center are claims, concrete statements such as someone's name, birth date, or assurance level. Issuer and subject identifiers specify who made those claims and who they're about. Validity and status define the credential's active lifetime and whether it's suspended or revoked. Schemas and types tell software how to interpret the data consistently. Finally, cryptographic proofs and trust metadata allow a verifier to independently check authenticity and integrity. A claim is simply a fact about a subject, a birth date, a country of residence, an age over 18 flag. Those facts only carry weight because an issuer stands behind them. A government-issued birth date is very different from a self-asserted one. For KYC, separate raw attributes like April 12, 1992, from derived attributes like over 18, and from decision evidence like approve account. Designing with these layers helps you avoid collecting unnecessary or excessive data. Credential types and schemas are what make automated trust workable. A credential type tells the verifier what kind of claim set this is, so the right rules and checks can be applied. The schema then spells out which fields appear, how they're formatted, and what they mean. Shared standards and governance keep different issuers aligned, so verifiers interpret data the same way. In practice, a verifier's policy should only accept credential types and schemas it explicitly supports. When a verifier checks a credential, they are really answering two questions. First, has anything been tampered with? Digital signatures, proofs, and issuer keys detect even tiny changes and confirm the data came from whoever claims to have issued it. Second, should we accept this for our purpose? That's a policy decision. Good architectures separate this technical validity from business acceptance. A credential represents a snapshot in time, not a lifetime guarantee. Start with the issuance date to understand when the information was last confirmed. Then check the expiration date. After that point, treat the credential as invalid by default. Next, consult the status reference to see whether it's active, suspended, or revoked. Finally, record what you checked and when, so KYC decisions remain auditable later. A verifiable presentation is a custom bundle your wallet assembles to answer a specific request. It doesn't have to send whole credentials. It can reveal just the claims the verifier asked for. The wallet also adds proofs that you're the legitimate holder, plus details that bind this package to a single transaction. The verifier then checks both the cryptographic proofs and whether the data makes sense in this exact context. Here's how a presentation flow typically works. First, the verifier specifies exactly what it needs: credential types, claims, acceptable issuers, and why it's asking. Next, your wallet searches for matching credentials and determines the minimum data required. You review what will be shared and with whom, and then give consent. Finally, the wallet sends a presentation the verifier can validate against its policy. The main objective here is to stop an attacker from replaying a valid presentation in a different context. Holder binding ties the presentation to a specific wallet or key, so only the real holder can use it. Audience binding defines who this proof is actually for. A fresh nonce or challenge links everything to one moment in time. Together, these controls make high-risk onboarding and regulated KYC flows resistant to replay attacks. Selective disclosure means revealing only what the decision actually depends on. Instead of demanding a full ID document, you request specific claims such as over 18, resident in the EU, or citizenship verified. Those are sufficient for KYC, risk scoring, and audit evidence without exposing full name, exact birth date, or full address. This keeps the onboarding platform lighter on personal data, aligns with GDPR minimization, and shrinks the blast radius of any breach. At this point, raw credential claims need to turn into concrete KYC decisions. Think in terms of questions. Who is this person? Are they allowed to use this product? How risky are they? And can we prove what we did later? Each attribute should have a rule, a purpose, and an evidence plan. Missing or conflicting data shouldn't be improvised. It should route to defined fallback flows or manual review, with only necessary evidence stored for audit. Validation outcomes should always drive a clear business decision. If everything checks out, the result is valid, and onboarding can safely continue. If a credential is expired or revoked, the default is rejection, unless your policy defines a fallback. If the issuer isn't trusted, the type isn't supported, or key claims are missing, you typically stop automation and route the case to manual review, capturing an auditable reason every time. Verifiable credentials are your signed structured facts: who the subject is, who issued the data, what claims it asserts, and whether it's still valid and trustworthy. A verifiable presentation is how those facts travel, packaged for a specific relying party with only the fields that request actually needs. From there, validation outcomes must directly drive onboarding decisions, exceptions, audit trails, and risk controls. Next, we'll turn these objects into live OIDC4 VP and OIDC4 VCI protocol flows.